All right, so before this topic, we will just do the system structure review, just as Dr. Chu and Steven said yesterday. So this is the typical system structure. And we need the control PC and the pure sending port and also the LED screen. That's okay. And the USB and Ethernet cable is for sending the control commands. And the HDMI, DP, or DVI is just for providing the video source to the controller. And the controller just transmits the data through the Ethernet cable to each cabinet and make all the screen working properly. All right, after that, the most we care about is loading capacity. We now start to only focus on the pixel level. So the first question is how to get the cabinet resolution. Let's see that. In the real cases, the cabinet dimension is about 5 millimeter by 5 millimeter, and the pixel pitch is around 3.91. And let's just check those formulas. The pixel resolution equals pixel width by pixel height. And the pixel width equals cabinet width divided by the pixel pitch. And the pixel height do the same thing. So we will just get the result like pixel resolution equals 500 divided by 3.91. Multiply 500 divided by 3.91. So it could be 128 by 128. So this is the way we calculate the pixel resolution for one cabinet. I think this was the most popular one in the market. So this is M-Control 300. And the loading capacity is about 1.3 million pixels. And for each output, it's really easy to calculate. We use 1.3 million pixels divided by 2 ports. Then we got 650,000. Once we know that, the next thing is about how many cabinets can be loaded by one output port. Because we know the port loading capacity and we know the way to calculate the cabinet resolution, then the next thing is how many cabinets can be loaded by one port. Let's check this cases. So the cabinet resolution is about 192 by 192, and each port got 650,000 resolution. And let's say it's really easy. So the cabinet number equals the port capacity divided by what? The cabinet resolution. So we get an answer like 650,000 divided the resolution is around 17. It's around 17. So some of you may ask why one port loading capacity is 650,000. And the next is the formula, the most important part in today's course. So here's the formula. 1 Gbps is the 10 to the power of 9, that is the bandwidth of the Ethernet ports. And the usage rate is around 93.6%. That one equals the capacity multiply the frame rate multiply the sum of RGB color depths. So I will just give you the hint like this. Okay, so the capacity equals what? Equals this range, 10 into the power of 9 by the right, and divided the frame rate so the capacity equals like that way. From this formula, we can either funny that, like if we reduce the frame rate, reduce the frame rate, so the loading capacity for one port could be increased. And also, for the input color depth, it's not only for 8 bits. Sometimes we have 10 bits or 12 bits. Sometimes we have 10 bits or 12 bits. But when we choose 10-bit or 12-bit, that one goes what? Cut down by half than the original loading capacity. The reason is the system rewards 1 byte, including 8 bits. It's 1 byte. And if it's over 8 bits, like 10 or 12, then it just enable another byte. But the algorithm of the system, we just reward that one used 2 times. So we've got this. This one turning to 16 and 16. So that's the reason why it's just a cut down into half. So please just remember this formula, and this is very important and really useful when you have a project. Okay, that one is about the formula. That one is about the formula. Okay, here are the capacity charts. So as I said, we just change the components inside of the formula, and then we got different loading capacity. You can just take a picture or make the screenshots. Okay, so let's move to the next page. All right, so at the classic controller, like M control 600, VX4S 660, and Nova Pro HP, that's all the full output controllers. And what about the loading capacity of them? Is that 2.6 million pixels? Actually, the answer is no. It couldn't be 2.6. Someone will ask like, oh, 650,000 multiplied 4, it should be 2.6 million pixels. And it's yes, but you got a limitation by the video input, So that one is 2.3 million pixels. And I will just give you the reason why here. The maximum resolution for single link DVI is around 9020 by 1200. So it's around 2.3 million pixels. So this is the limitation, which makes the full output sending card cannot reach 2.6 million pixels. That's the limitation. That's the limitation. But no worries. We know Sunrise a new product, the MX40 Pro, which will be introduced on Friday. My colleague Gary will just give you the hint about this. Okay, let's get it back. So the single link UI seems to pull like 1024 by 768, and those kind of different resolutions. But still, we can do the customized resolution as well. And also for the single-link GUI, still we support some special resolution, like 2048 by 1152. It's over 2.3 million pixels, but the device doesn't support that. And also another one, the 2560 by 960. It's over 2.4 million pixels, but it's also work. That's all about the bandwidth. So the next chart is about the video bandwidth. So please just take a picture or just make a screenshot. That's really important. And here, you just figure it out. The display port 1.2 is 4096 by 2160. And that one just explain why the pure sending card and control 4K resolution is around, yes. Okay, just take a picture or make a screenshot. Okay, here's just the types of the controllers like MIC 300 and M-Control 300. The loading capacity is 1.3 million pixels. And for the 600, it's 2.3 million pixels. So still the same thing, take a picture or make the screenshot. That's it's all the parameters here. The most important thing in this chart is around the maximum width and the maximum height. That means, example, the MIC 600, the maximum width up to 3840. That means your screen cannot over that width. And for the height, we just use 2.3 million pixels divided by 3840. Then we get the height. It's just like 3840 by 600. So if the screen is just like this way, that resolution, we could just use MIC 600. And other things be the same. Okay, the next important thing is the M-Control 4K. The M-Control 4K. So you've got the 7680 is the maximum width. The reason is we need the graphic card to support that one first. Once the graphic card had the DVI outputs, and we can move that down just from left to right. And we could just make it 8K by 1K screen. And also for the common situation, M-Control 4K supports 1496 at the width. But some of you will ask, I can just rotate the knob on the front panel of the 4K and it's just turn into 1492. Yes, it's just on the front panel. But if your graphic card support the real 4K like the 1496 and get to the M-Control 4K, then everything will be fine. And 4K will just detect the resolution and show it on. Okay, this is about this chart. All right, we know how many cabinets can be connected, but is that really enough for the real project? Let's check it out. So this is a real plain case, The screen resolution is just 9020 by 1152. And each cabinet is 192 by 384. 10 columns in the 3 rows. Yeah, the customer only have M-Control 660 in stock. And the system must run at 60 Hertz. So remember remember that formula, and the frame rate should be 60 only. And let's see what's going on there. So we do the string connection here. We do the string connection here. There's 1, 2, 3, 4, 5, 6, 7, 8, and we do the thing as usual. But it will just give the warning like exceeding the load range. You may ask, no, it's not over the loading capacity. I only connected 8 cabinets. Right, I only give 8 cabinets here. It's just less than 650,000. All right, so let's say why it exceeds. The system is always the system. It's not a human being. So they will just regard all the cabinets at the full rectangle. So no matter if it's 8 cabinets or 7 cabinets, it's always recognized by 9 cabinets, the full rectangle. So that's the reason why the software gives the exceeded warning. And also the same thing, the MX40 Pro will just solve that kind of problem. It got no any limitation like this. So we change the diagram here. And it works properly, So here's a new diagram, right? Put 1 horizontal way, and make a U-turn like this. And it's working. All right, after that, next thing, we're going to talk about the standard steps to configure the LED screen. Here we got the 5 steps. Step number 1, the graphic card settings. Number 2, sending card settings. Number 3, receiving card settings. And number 4, screen connection. Number 5, LED screen content display. Okay, let's say the first, the graphic card settings. Will we just plug the Windows and P together on the keyboard, and it will just pop up like this way. And we have the choices like extend and duplicate. Yes, and now we're doing the left show. We have to use the extend mode because we are running the Zoom software. So we choose the extended mode now. And what is duplicate mode? It just show everything on the screen, what you are doing now, and synchronous to the LED screen. And the next part is about the display settings. We have to make sure the resolution is good one, and also we have to change the size of the text. The scale and layout, we have to make it 100%. We have to make it 100% to make it a pixel to pixel. All right, here we go. The most familiar parts, the NOVA LCT. Once we click user and advanced synchronous system user login, and then we can just enter the configuration modes. And the password is ADMIN, all the small letters, Once we enter the advanced mode, then we just click that one, the screen configuration. And here we go to this page, and here we got the 3 tabs. The first tab is sending card. What can we do here? we just set the source configuration, like the resolution of the source and the refresh rate of the source, and click Cite. That's enough. And we just select the input source for the device. Make it as HDMI, DP, or DVI. It depends what you're using now. And also, the last thing is about the display mode. The display mode, we have to make sure the sending card resolution equals the graphic card output resolution. We have to make sure those values are same, and we can get the pixel to pixel effect. And don't forget, click Save. All right, here we go to the receiving card type. Receiving card type. Once everything you've already got from your screen supplier, and then we just do one thing: load it from file, click the correct file, and then everything will be fine by clicking Send to Receiving Card. And here we got the options like all receiving card or specific receiving card. If every cabinet had the same resolution, the same sending card, same receiving cards, then you could just choose all receiving card. But you know, in real projects, sometimes the cabinets are not the same thing. Sometimes it's just a bigger one and a smaller one, just combined together. So at that time, we have to choose the specific receiving card and give the corresponding RCFGX file to the specific receiving card. So that's the one we have to choose. And after that, we check the screen. Everything is working properly. Then we can just click Save. All right, still on this page, we could do the thing like read from receiving card. And here in the parameters like read which one. Okay, read the receiving card under sending card 1 and the port number 1 and also the receiving cards. So that depends which one you want to read that. You want to read that. Once you read it, and we can just save that one to file. Once you just finish one project, we could do the things like that and send those files to the end user. All right, so now, without the screen connection, each cabinet will just display the same image like this, just like this way. You can see all the cabinets show the same thing. So once the screen is like this, don't worry. Okay, let's say the third tab is about the screen connection. It's about the screen connection. And let's see what we can do here. First, we just give the quality of the screen just to tell the software how many screens we have here. And next, we tell the system like how many cabinets we have, just like how many columns. For this one, 4 columns and 2 rows, and we will get this. And then once we have these 3 parts, the next thing is we choose the sending card number, which sending card you are going to configure and which ports you are going to configure. Anyway, don't forget the receiving card size, And one thing is really, really important. That is, the receiving card size is not the dimension size. As I said from the very beginning, we only focus on pixel level. So the 128 by 128 is the cabinet resolution. Do not forget this. And then we do the data flow like this way. And also, we could just choose that one from the quick connection. That depends. And the same thing, send to hardware, tell the hardware that we are ready, and now is the correct one to go. And don't forget to click Save. And at this tape, we got a new function like enable mapping. You may ask, what is mapping? Let's check it out. So once it's connected, I mean, all the cabinets have been connected, but it's not real configured. It's just like this. And sometimes, you know, in the real project, it's really hard for you to go to the real side of the screen and check the cable unless you know everything. But sometimes we have no luck. So we have to stand in front of the screen. So what we can do, and that's that, enable mapping function. Here we've got the squares like P01 sharp 001. The P means the port number 1, port number 2, port number 3, and port number 4. And the sharp means the receiving part. The first, the receiving part, the second, and the third one, the fourth. So they got a different meaning for those numbers. Just remember that, please. Okay, this is about mapping, and then you just do the thing like correct the data flow by seeing what? Yes, by seeing the mapping, and you will get it. Right? It's really easy for you. Okay. That's in the next scene. Still the same. You can just save that one to file or just load from file. The same as the receiving part tape. The same thing, same meaning. And all the files just end with .scr. Like example.scr. So you can just load it. Anyway, it's an easy one. And another one, the detected communication status. That is really important features as well. You can just read all the status if it's communication is good or not. We can check the status and we can just find the problem. So for now, each cabinet just know exactly what it shows. And then we will get the complete image. Well, here is the summary. For the graphic cards parts, we have the duplicate mode. Just easy to observe the screen connection status. If you just want the every screen just show the same thing as our desktop, then that would be cool. And next is the resolution or scale. That settings is all about the pixel to pixel level display. Pixel to pixel level display. Okay, and let's say what NOAA LCT can do. The sending card settings, we can change what? The resolution and the frame rate. And also for the receiving card tape, we just load the files or do the smart settings. Anyway, I just suggest we have the file. That would be cool. And the third table is about the screen connection. That one really according to the real cable wearing. You know, different project, different size, different cabinets. So you have different choices. So that depends. But anyway, don't forget, we have to make sure that is front wheel, the cable wearing, we need to make it sure we stand in front of the screen. All right, here's all the things about how we can configure the screen. But what is the next part? We have to make it working properly all the time, right? So the next thing is about stability. So it's a Cascading and redundancy configuration. So what and why cascading? We need it. Why we need it? So let's check it out. What is cascading? Just move all of those. We just focus on those two M in Control 660 Pro. That one means cascade. Just from the first and the second, we have the USB cable between them. We have the USB cable between them. That means cascade. And why we need cascade? The project may have the real huge screen like over 8K, but you do only have the M-Control 4K in your stock. So you have to use several pieces of the sending card. But what if you have the higher loading capacity device like H2 in your stock? That would be cool, right? H9, H15, then that would be cool. And tomorrow, my colleague Ricky will just introduce those kind of flagship products, the H series. But anyway, for now, we don't have so much stock, right? If we don't have stock, so we have to cascade several controllers to run the project, Okay, and the second is for redundancy configuration, All right, that's the next part. The cascading connection. We just check different types of the cascading connector. Now here's MSC 300 and the MSC 600. So it's just using the very old pin connector, the 5-pin connector. We have to use this kind of short cable, and that's the G18 is for UART in. The G6 is for UART out. We have to make the first device connect to UART out, and to the next device UART in. We have to make things like that way to make sure the cascading is working. Okay, the next is the cascading of M-Control 300 and 600. So we integrate the 5-pin connector into the small round connectors, and we change the cable as well. So it's really easy for us to find it in the box. Still the same, we have to make the UART out directly to the second device, UART in. That's really a classic devices. And what about the M-Control 660? We change it because sometimes the device in the stock is for a long time and you just lost that cable. So we change the UART in and UART out as RG45. That's really easy. We can take it everywhere, right? And for latest products, we provide like USB for cascading, like M-Control R5 using USB, and M-Control 4K using USB. UHD Junior, and VX standards. The new products we use USB for cascading. Okay, just one thing. Cascading won't work if the PC connects with the Ethernet port. So that means we have the computer here and we have the device here. We use the Ethernet cable, give the control command, and you just use USB cable cascade connects device. That is not good, not really cool. So we cannot use that this way. We have to use USB as well from the very beginning. All right, this is the way to check if the cascading works. That's really easy. We just need to launch the NOVA LCT and just the wheel details of the device. We can find it too, and also we can just check if the current operation ports. We only can find one port, then that will be cool. One COM port, two devices. That means we get succeed. All right. The next thing is, why do we need redundancy backup? You know, the lecture like if the LED at the background, you know, it's really hard. It's being tough if one part is slack, right? So let's say the weakest part in the whole system could be the Ethernet cable, Let's say the PC, the video processor, and everything is working properly, and the screen is full, it's working now. And that's that. The artificial part is the weakest part in the whole system. Once it's broken, cracked, you got what? Got a blank screen. Screen blank is not really a big deal, but the big deal is maybe you cannot just collect the money, right? And what we can do here, we just give the redundancy channel. Give another device to make the backup. And even the cable here disconnected, and it still provides a good pictures here. By the way, this type is only for what? Only for the Ethernet cable level. So what is the receiving card dead, or the sending card dead, or power supply dead? Nope. If one rest of them happens, it still goes there. So we have another solution like dual power supply mode, and we got dual receiving card backup. And to make sure the whole system working really stable. All right, we know about what is backup and the meaning of it. And let's say how to set the backup. Let's say from the NOAA LCT. All right, the first is redundancy on single unit. That means what? The screen is really the small one, and still we have the available ports, just like this. The port number one, yes, we could just load the whole screen. And the port number two, we just need to what? We just need to put one Ethernet cable to the reverse side of this screen. This is the structure. And let's say, what should we do from the software? All right, the same thing. Check everything, just the COM port is okay, check the device is full, and then we move to what? Move to screen connection tape. We give the correct the layout of the cabinet here, and we give the correct resolution size. Don't forget that resolution size, not dimension size. And we choose the correct, corresponding Ethernet port and do the connection, give the correct data flow from the front wheel, and then send to hardware and safe. And this is the first step. The second step, we have to back to sending card tape as well. And at the very bottom side, we have the redundancy settings. We have to click add first. And here is the number of primary controller. Now we are using one device, right? And we have available ports for backup. So the number of primary controller is one. The number of backup controller is one as well. And just using different ports. We just definite all the things and click add. And still the same, don't forget to click send and click save. All right, what about the screen is really a big one? What about the screen is a big one? The one device cannot hold it, right? So there is a big screens or one more available controller. We can do the backup. Let's see the structure. Let's see the structure. Here is 2 in control 66 row, right? We do the same thing. Load that, and take the backup ports, what? Yes, plug into the reverse side of the primary string. And let's say, what can we do from the software side? Still the same thing. We check the COM port is working properly, and we have 2 devices here. And also the same procedure. Only set the configuration to sending card number 1. Just please remember that. That's really a different part for the next part. I will just tell you the differences later. Okay, for this part, multiple cascaded units, we only need to set the configuration to sending card number 1. That's enough. Yes, everything is the same procedure. Okay, we're back to the sending card as well. So we click add and do the same thing. Number of primary controller 1, and we have a new controller now. So the number of backup controller should be what? Should be 2. And we just give the corresponding ports. So we just use primary port number 1 and backup port number 1. That's just for example. For the real cases, it should be real long term. Okay. Then click add and save to the hardware. Okay. Yeah, the same thing here. The port number 1 for unit number 1. Backup port of ports number 1 of unit number 2. Okay, that is for cascaded devices. But what if it's non-cascaded unit? So it's still the big screen, and we have more available controllers. Let's say we got no USB cable anymore, but we have 2 devices. We have to make the backup for them, and we have to make the screen really stable during the live show. And what can we do here? Look, now we have to use the loop sensor to provide a 2 video signal, and all the structure is the same. And let's say what's the difference here? So for now, launch the no LCT, click the screen configuration, and you will just get what? With details of devices, you will just find still got 2, but it's just a 1 by 1, not just like previous one. It shows 2. It's just a 1 by 1. And for the COM ports, it has 2 options as well. It has 2 USB ports, detected. All right, let's say what we can do from the software side. First, we have to make sure it's just the main sending cards, right? Configure the primary sending card, and all the procedures are the same. Give the correct quantities, how many columns and rows, and also give the corresponding Ethernet ports and the correct receiving card resolution size, okay? And just to give the correct data flow, send, click, save. This is what we do to the primary sending card. And then we're back to the sending card tape as well. And here's really easy. We just click set as primary, that's enough. And don't forget to click save here. All right, then what about the backup device? Here we just choose the second port. And we load from the file, give the same data flow, the same file, the direction, everything is the same. And send to hardware and click save. So that's the differences. For cascaded devices, we only need to configure 1 time, right? But for the non-cascaded, we have to configure the primary, and still we have to configure the backup device. So that's the difference. And also, we're back to the what? To the sending card tape. Sending card tape and give it like set as backup, set as backup. And don't forget to click save. Yeah. In order to we have the things like from the device front panel, just rotate the knob and press the knob, right? We can just do that, advance the settings and choose it as a primary device or the backup device. And later we will just show you. Okay, now let's say the practice of the backup, Okay, here we move to the screen, Okay, let's see the screen here. Okay, so for now we can see the screen, right? We can see the screen here, right? And the thing we're going to do is start the backup from the front panel. All right, everyone, if you can just say the screen and the controller and me inside, please just press 1 into the chat. We have to make sure you can just check everything. I think now it's cool. Let's say those are 2 devices, the M control 4K, 2 pieces of M control 4K. And here we use one port to load the full screen. And we have another one as backup. Now, we just reset everything. Okay, this is backup. This is backup force. This is backup. And this is primary. And you can see it all goes black. So the first thing we have to do is go through the menu and press the knob here. And move to the advanced settings. Make sure that redundancy works as primary. And then we go back to the screen settings. Give a quick configure. See, we just learned about the way to configure that, right? So for this down here, comment row quantity. How many rows? 3 rows, right? 3 rows. So we give the parameter as 3. And in columns, right? 1, 2, 3, 4. So the columns will be 4. The columns will be 4. And the port number 1. So for one port, we have what? We have 12 cabinets. We have 12 cabinets. And you may ask, why? The whole string is not working properly. The whole string is not working properly. Right? I think the second one, yes, the rows and the columns is right. But why is not at all? And let's say the front panel. Let's see the front panel. It's about the data flow direction. Data flow direction. That's the wrong way. So we have to make it sure it starts from the left bottom corner to the top, and then go right and go down. Go that way, and then we click it, and then all things will be configured for the primary device, And don't forget, save to hardware. Okay, this is for the primary device, And I plug it out. We move to the backup device. All right, still, we do the same thing. Press knob and give me quick configure 3 rows, 4 columns, and 12 cabinets, and we give the correct data flow. Okay, we make everything works properly, and we move to advanced settings, and give the redundancy as set up, and save to hardware. Okay, now we put the primary ports into the primary device. And we put the backup ports into the primary device. And now let's say we unplug the primary. So that I plug it out. The cable doesn't disconnect it, but the string is still working here. It's still working properly, right? Okay, let's say I will show you again. Now, I plug out 2 cables, and this is primary. And this is backup to the backup device. Okay, the whole system is cool. And now I'm going to unplug, right? Going to unplug the primary ports. It's still working. Now this is the way we set the backup. And I hope this one is really useful for you in the lectures. All right, now we're just turning the redness down to 0. Okay, we're back to the presentation. All right, the next part is about the troubleshooting methods. And indicator status of the receiving card. I think that's a real important thing for you to check the string status by the indicators. So let's say when it's working properly, working normally. flash 1 time per second. That means working normally. And let's say, what about it's working normally and it's just working the backup mode like what I did. Quick flash 4 times in half second and flash again 4 times after half second interval. Right, let's say that again. Yes, 4 times in half second and after half second interval and 4 times again, 4 times flash again. And let's say the network cable is now connected. It's just slow flash. It's a long term. And the next one, no signal input. No signal input and the network cable is not connected is really the different part, really different thing. The no signal input means the sending card has no video input. And it will just directly show only what? Only receiving card indicators. We only focus on the green indicators, and the power indicator goes red. The green is about FPGA. Okay, no signal input, quick flash 4 times half second, and flash for flash 3 times again after half second. Yeah, let's check it out again. 1, 2, 3, 1, 2, 3. Once again, 1, 2, 3. Yeah, it goes like this way. So let's check them out. The first one is working backup mode, and the second one is just working normally, and the third one, the top left corner is a network cable disconnected, and the last one, the bottom right corner is no signal input, so no signal input. All right, here we can do the summary. The receiving card green indicator lights normal flash 1 time per second. And the backup mode is false flashes 4 times at 0.5 second intervals. Like 1, 2, 3, 4, stop. 1, 2, 3, 4, stop. 1, 2, 3, 4, stop. Things like that. And the certain network cable is disconnected. So it flash 1 time in half second. It's really a long-term flash. And the last one is no signal input. Flash the flash 3 times at 0.5 second intervals, like 1, 2, 3, stop. 1, 2, 3, stop. 1, 2, 3, stop. Okay, this is about the green indicator and what the meaning of that. And about the screen blackout, if the screen blackout is for the full screen, so we have to check the sending card and check everything, like the receiving card indicators working normal or in other modes. If everything goes well, then we check the video source, the sending card, right, the brightness of the screen. And what if it's just a blackout part of the screen? Yeah, we have to just check the sending card output level and cabinet level. Maybe the cabinet PSU, power supply unit is cracked or broken. And the module level, the module crashed or something like this. So we do the cross addition, and we can just check the troubleshoot table and the solution. All right, here is the summary of the troubleshooting. All right, the last part, and this is the most important part in our daily work. For our FAE, we have to use the screen control and test the tool every day, actually. Once the client says, oh, please my screen is not working or flashes or something. And then we always tell them, what about you give the screen control, it's still like the same thing? And next, I will just introduce why we are doing this, Okay, let's say, what is the screen control? Screen control means the signal is from the receiving port directly, from receiving port itself. So that means without the sending port, we still can do what? Sorry, without the video input, still we can do the screen control. So let's say we're to enable that. Let's say no activity and get the screen control here. Click the screen control here, and you got several choices like normal, just working properly, and give the test pattern like red, blue, white, the pure color, and also the horizontal flashes, lines. And this is the way we communicate from the front panel of hardware to that display control and the same thing, the pure color or the flashes. Just to remember, all things is from the receiving part. So that means if the screen not working properly and you do the screen control, but the screen control shows every flash is clear and the color is correct, then we move back to the front side, like the video, like the sending part, or the computer. All right, the next thing is test the tool. The signal is from the control PC. So that means we have to check the whole system. All right, the test tool is a resolution measurement. So here is the coordinates, here is the tape of the tester tool. We have to set the coordinate like the X, Y, and make sure where you started from your screen. And also the width and the height is about the tester port resolution. And still, we have the grid test, like the pure color, flashes, horizontal, and we can give the settings. Okay, that's it. Maybe it's not really clear, but still we can find the horizontal lines is not really clear. But the top one shows correctly. So for this one, we have to check the RCFP files maybe, or the resolution, yes. The resolutions. Yes, all the files, the resolutions, we have to check. And once everything is properly, then it goes like this way, the top way. Okay, the last part is orientation settings. And this one is for locating. The problem, where the problem is. So we give the module information like the width is 104, the height will be 26, and numbers of the columns, right? One column, how many rows? 4 rows. For this module, it has 1 column, 4 rows. So we give that 104, 22, and 1 columns, and 4 rows. And then we give that from the left to right, and then we will get this picture. And we will just easy to figure it out which part has issue. But actually nowadays we have the mapping. So this one is mostly used for the data exchange, All right, this is all the things about today's training.
Okay, hold on a second. All right, by the way, once I'm going to use the Ethernet cable and the control cable, we cannot use the USB cable cascade the second device. It's not really the correct way to use it. We have to use the USB cable from the very beginning, from the laptop to the first device. and just use another one cascaded to the second device. Okay, here we go. We got the control system now. All right, we can have a look. We can have a look. Now, view details of the device, the M control 4K, just the one pieces. And we go through that. It's COM port number 1, COM port number 1. All right, let's just check the sending card. As we know, you will see why the screen is just black, why the screen is black, right? We got no reasons, and we don't know what to do. And all the things like the indicators is working properly at the rear side, I mean. And we check the receiving card. We check the receiving card, and we read it back, read the file back. It's just the normal one. We got it from the what? We got it from the manufacturer. It's cool. And we check the screen connection. We check the screen connection. Read from hardware. As I said, it's just from the top left corner until up, to right, and down. And the screen is working properly as well, right? The connection is working properly as well. So everything you think, oh, it's cool. What can we do? Maybe we can just try the screen control as I said. No, still nothing. Still nothing here. Back to normal. All right, it's just still the same. A second. Now, everything is still black. Everything is still black. And even we just click the screen control, right? But we can just check because the camera, so you cannot see the rear side. Actually, for the green indicators, it's working probably like one time, per second, one time per second. So let's check out. Is there anything could just cause the black? To press the knob here, well, we found the brightness is goes to 0. The brightness is goes to 0. And just make it higher, Okay, 16. So, and another thing just to prove, if we just change the brightness from the controller and the screen just goes to 0. And even we just click screen control, it doesn't show anything. It didn't show anything. And what does it mean? What does it mean? That means all the brightness parameters saved into the receiving card side. Saved into the receiving card side. That means we've already made the receiving card goes to 0. And we make the screen control, and it won't show anything. It won't show anything. All right, that's just a simple way to make the troubleshooting. And then now let's say, what can we do from the screen configuration? We gave it factory reset first. Factory reset, and we have to make them back to original. All right, you can see the screen now. Okay, you can see the whole screen here and also my laptop. So just do, okay, cool. Now, as I said, if every cabinet shows the same image, but it's not the whole picture, that means what? The RCFDX file is working properly, but we don't have any Yes, we don't have any screen connection data file there. So let's say, what can we do? So first of all, we have to make sure one thing, that how many rows, how many columns. That's really easy for us to count, right? The 3 columns, oh, sorry, 4 columns, 3 rows. So we give it 4 columns, 4, and rows 3, rows 3. And you remember, we have the mapping function, right? And that's that. And that's that. This means sending card number 1 and the port of the sending card, right? Port number 1 and receiving card number 1, right? Sending card number 1, port number 1, receiving card number 2. So we can check it out. For the whole screen, we just use 1 sending card and 1 Ethernet output port, and we have 12 receiving cards. Okay, we check it out. So we do the same thing. We from the bottom left corner, give it up to right, and do the same thing as what it shows here. And click send to hardware. It is sent to hardware. And someone will ask, wow, it's cool or not? I don't know. Please just remember, you just enable the mapping function. Do not forget to close it when everything is down. All right, the same thing. Save it, save that one to file. Save that one to file. And it will just show us .scr. Also, for the receiving card, once we have the file from your manufacturer, and then you could just click load from file and choose the proper one and load it, Yeah, because this is not the correct one. All right, this is the way we do it, and still the same. We can just read the file back here and save to file for your end user. You can just tell them, this is the new screen. Yeah, this is the new screen, RCFG, something like that way. And they can just load it. And once the screen got any problem, we can just resend the parameter and everything will be cool. And the last one is the sending card, sending card tape. Yes, we have to make sure the sending card resolution should equal the graphic card output resolution. That's really important. We can make it pixel to pixel. All right, this is a basic way we do the configuration for the screen. And the next part is we set the backup. And we have 2 pieces of 4K here, and we don't have any cable to cascade them. We only got the USB cable for the primary device. And we have another device as backup. And now we just remove this control cable. We remove this control cable. And now let's make it work. So we connect to the first device and we do everything. Like send to hardware and everything, make it working properly. And then we back to sending card and give it what? Set as primary. And do not just forget to click save. Okay, so for this device, it's a primary. It's a primary one, and now we back to the next device, the second device. And still the same thing, we send, we just plug that cable into the backup device. And we do the things like how it goes, let us say how it goes, right? We do the same thing here, up to right, up and down, send to hardware. Send to hardware. Okay, and close mapping and click save. Okay, and then we go through the sending card. And we make it as backup. Okay, now we plug it out and plug it back to the primary. And don't forget, click save. Okay, and let's say, what if we just plug it out here? We remove, right? We remove the primary device. We just unplug the cable here, and we make it back. This is the backup port. This is the main port. Okay, we have the main port. It's working, and we have the